problem says we want to look at the partial fraction of 1 over x, x plus 1. So things to recognize that it's already factorized for us. Sometimes it's not factorized. It may look like this, it may look like that, or this guy. And we need to factorize the denominator. It's already factorized for us in terms of two linear factors. And the degree of the top, that's 0 degree. So it's less than the bottom, which is 2. So little things to recognize. The moment we recognize that, we know then we can write this in partial fractions. It's a over linear factor plus b over the linear factor. So that's important to note. And once we do that, then we're in a position to recombine this set of fractions. I'll write this out and then later I'll just work with the numerators. When we go to recombine, we talk about fractions and I give you my formula. Well, let me give it again. It's a over b plus c over d. This is the only formula we use for fractions. Gives ad plus bc over bd. That's the idea. So in this case, we have a times x plus 1 plus b times x. And this is over x into x plus 1. Notice that my denominator is the same as this guy. And so I can now say that the numerators are equal. So thus a into x plus 1 plus bx is going to be equal to 1. That's the idea. And now the next time I work these problems, I will forego this step and I will jump to this one to work on numerator only, because that's where you really want to get. The denominators will work out if you set it up right, and we're good to go. So here goes. The simplest way to work this guy is to go ahead and say, hey, take x equal to 0. Why can we do that? Because this expression, this equality, works for all x. For all values of x, this works. So we can say just take x to be 0 and it works. Take x to be 0. Notice that we don't have this part inside our equation. We get a x is equal to 0. So this is a times 1 is equal to, this is 0. A is equal to 1. When we take x equal to, and we spoke about that, the next time we're going to take x, we're going to take x equals to -1. This will make this disappear. Why are we choosing zeros? We just essentially put 0 in the denominators of these, and it works out that it kills these terms. Kills a b in the case of b, kills a in the case of x equals to -1. So we'll take x equal to -1. And if we take x equal to -1, the a term is gone. We're going to get b times -1, which is well, let me write it here. B times -1 is equal to 1, or this means that b is equal to -1. And so we have now computed our terms a and b. We go back and say, therefore, 1 over x into x plus 1 is equal to, a is 1, so it's 1 over x, plus, well, b is -1, so I'll just put a minus here. So minus 1 over x plus 1. And that's the way we normally treat this. Why is this useful? So this would be your final answer at this point. You have resolved those things into partial fraction. Why is it useful? Because if we wanted to integrate, like the problem asks, we will now integrate both of these. And this integral will now be easy. That's just ln of x minus ln of x plus 1 plus c.